Hey YouTube, welcome back to another episode in my LeetCode series. In this one, I'm going to be tackling problem 108, convert sorted array to binary search tree. So, given an array integer nums where the elements are sorted in ascending order, convert it to a height balanced binary search tree. So what is a height balanced binary search tree? A height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than one. So let's take this tree for example. We couldn't have a 10 here, a 15 here, and then a 30 here, because then the difference of the two subtrees, -3 and 9, this one would have a length of 1, while this one would have a length of 3. So pretty self-explanatory what that is. And let's just go straight into solving the problem. So the first thing we're going to do to balance this out is we need to find the middle element. And the middle element is going to be our root in every case. So I'm going to define mid as the nums.length divided by 2. And I'm going to floor this value, just in case we get a decimal. We can get a whole number when we use floor. Now you might be wondering, why aren't we using math.ceil, which does something similar, just it rounds to the higher number rather than the lower number. Well, let me give you an example with ceil. Let's say we had an array of 1, 5, and 9, and here the nums.length is 3. And if you took 3 and divided by 2, you'd get 1.5. And if you ceil this, it would give you 2. And then 0, 1, 2, you'd actually be at the end of the array. Your root would actually be at the end of the array, where if you were to use floor, if you were to floor 1.5, it would give you 1, and 0, 1 is the middle, which is our root node. So that's why we use floor and not ceil. So now right here we have the definition for a binary tree node, and in order to make our tree, we're going to have to instantiate this. So I'm going to define a root, and I'm going to say let root equal to new tree node, because we're creating a new object instance of tree node. And we're going to pass nums of mid. So right here we're defining our root as the middle element in our array. Now you might be wondering, right here when we're creating our tree node, why are we not passing a left and right value? Because obviously here in the definition we have value, we have left, and we have right. We're actually not required to do so. And you can see we have conditions right here. We have this dot left. And if left is undefined, it'll just be set to null. And if right is undefined, it'll just be set to null. So we don't have to worry about that now. So we actually do have to worry about it now, because we're going to do it now. But I'm going to show you how to take care of the left and the right subtrees. So let's say our root dot left, because our root has a left value, we're going to set that equal to sorted array to BST. And we are going to pass in nums.slice 0 and mid. So what am I doing here? I'm recursively calling this sorted array to BST function for the left. What does the slice method do? Well, the slice method gives you a subset of an array, and the boundaries are defined here, 0 to mid. So we're going to create a subset of nums, which goes from 0 to the halfway point. And we're going to recursively call this function to create the left side of our tree. Because you can see once this is called again, there's going to be a new root, which is connected to the original root. And then that's going to be split up, and we're going to do that over and over again. And now since we did that for the left side, we also need to do the right side. And here we're going to pass mid plus 1, which is all we need to do, because in JavaScript, if you leave the other parameter blank, it'll assume that it's from mid plus 1 to the end of the array. Now, you might be wondering, why doesn't this just loop forever? And you're right, it is going to loop forever right now because we have no base case. In every recursive function, we need a base case. And that base case is going to be if nums.length. So if nums.length no longer exists, that's going to be our condition, because again, we've looped through the array enough times to where we've created our tree and we have no nodes remaining. If the nums.length is not there, so if it's falsy, then we're simply going to return null. Now let's run this and see if it works. And you can see we got an error. So what did I do wrong? So there's two issues here. The first one is I accidentally left ceil in here when we're supposed to be using floor. The second issue is we're never returning the tree. So I return root and this should work. And as you can see, we got the right solution. Thank you guys for watching. Like and subscribe if you learned something, and I'll catch you guys in the next one.